We wish to apply concentrated forces at 2 points on the right edge of the plate. However, it isn't possible to select 2 points on this edge the way that it currently is. So what we're going to do is create two partitions. The partitions are going to lie along the length of the plate. The points at which the partition lines meet the right edge of the plate will become selectable nodes. In order to create the partition lines, we're first going to create 4 datum points. We'll use the Create Datum Point Enter Coordinates tool. We'll type in the coordinates of the datum points when prompted by Abaqus to do so. Now let's use the tool called Partition Face, use shortest path between 2 points. We select the start point and then the end point to create one partition. Then click the Create Partition button. Now that you've created one partition, you've got 2 faces, so Abaqus needs to know which face you plan to partition next. So choose the lower face and then click Done. You can now partition this face by selecting the next 2 points. Now let's apply our concentrated forces at the newly created nodes on the right edge. Next, let's mesh the plate. We can assume that the strains in the plate will be small. Hence we're going to go with quadratic shell elements because they give good results for thin shells with small strain. We'll seed the edges of the plate by number. We'll assign 3 elements to each segment of the shorter sides. This means we'll have 9 elements on the left edge and the right edge. We'll assign 10 elements to the horizontal edges. Notice that I selected all of the partitions while doing this. We then tell Abaqus to go ahead and mesh the part. Now that the setup is complete, let's create and run the job. Since we did not specify history outputs, and in fact deleted the pre-existing one, Abacus warns us that no history output has been requested in the load step. We're going to tell Abacus to continue with the job submission by selecting Yes. Once the analysis has completed running, right-click on Plate Job and choose Results to view the visualization module. We're going to tell the Abacus viewer to display element labels by going to the Common Plot Options tool and checking off Show Element Labels in the Labels tab. We can plot our field output as contours by using the Plot Contours tool. By default, Abacus will plot the Mises stress. We can write these to a report by going to Field Output in the Report menu. We'll check off Mises stresses. In the Setup tab, we can give our report file a name, and we'll uncheck the Append to File option. We'll tell Abacus to sort the table by Mises stresses in the descending order. We'll also tell Abacus to write out the column totals and the minimum and maximum values in the column. Since I've performed the simulation once before, Abacus warns me that this file already exists and it's going to be overwritten since we unchecked the Append to File option. You probably won't get this warning message if you haven't performed the simulation before. I'm going to click Yes. Notice that the report file has been created in my Abacus working directory. I've set my working directory to Abacus temp in the C drive, but yours might be different. By default, it's likely to be the temp directory in the C drive. I'm going to open up this report file. Notice that one of the columns is the element label. This is why I made you plot the element labels on the plate before. You can now tell what the stresses are on each of those elements. Abacus has also written the minimum, maximum, and total values at the bottom of each column since we checked off those options. And that concludes this tutorial.